In this video, I want to have a look at the factor theorem. So the factor theorem follows on from the remainder theorem, and it says that for a polynomial p of x, if p of a equals 0, then x minus a is a factor of the polynomial. So let's have a look at the proof for that. So once again, we know that we can write a polynomial p of x as a of x, the divisor, times q of x, the quotient, plus r of x, the remainder. Now, if we let a of x equal x minus a, we're going to have p of x equal x minus a times q of x plus r of x. From the remainder theorem that we looked at in our last video, we know that if we divide p of x by x minus a, then our remainder is going to be p of a. So we can write that in. So we'll write p of x equals x minus a times q of x plus p of a. But in our definition up here, we're saying for a polynomial p of x, if p of a equals 0, then we're trying to prove that x minus a is a factor. So we're going to let p of a equal 0. So we know that p of a equals 0. So that's going to leave us with p of x equals x minus a times q of x plus 0, but we won't put that plus 0 on because it doesn't make any difference. So we're just left with this, which means that therefore x minus a is a factor of p of x because it's just a multiple of a quotient. Now the converse or opposite of that theorem is also true, so it works backwards. If we know that x minus a is a factor of the polynomial p of x, then we know that p of a is going to be equal to 0. So it works both ways. So let's have a look at how that helps us to solve problems. So our first example asks us to show that x minus 2 is a factor of x cubed minus x squared minus 14x plus 24. So to do that, we're going to find p of 2, and if it's a factor, then this should come out to equal 0. So we're going to have 2 cubed minus 2 squared minus 14 times 2 plus 24, which gives us 8 minus 4 minus 28 plus 24. And if we figure that out, it does come out to be 0. So therefore, x minus 2 is a factor of that polynomial. Our next example is a little bit more in depth. So we can use the factor theorem to help us factorize polynomials. So this question asks us to use the factor theorem to find factors of p of x equals x cubed minus 5x squared plus 2x plus 8, and hence write that polynomial as a product of its linear factors. So we want to factorize it right down until each factor only is of degree 1. So we only want them to be linear. Now to do that, first we need to find one factor. To do that, it's just sort of guess and check, but educated guess and check. So for example, if we wanted to check whether x minus 1 is a factor first, we'd test p of 1, and we're going to substitute 1 in here. So we'd have 1 cubed minus 5 times 1 squared plus 2 times 1 plus 8, which gives us 1 minus 5 plus 2 plus 8, should give us 6. So therefore, it's not a factor. So that one didn't help us. Let's try something else. Let's have a look and see if x minus 2 is a factor. So we're going to have a look at p of 2. So we'll have 2 cubed minus 5 times 2 squared plus 2 times 2 plus 8, which will give us 8 minus 5 times 4 plus 4 plus 8. So we've got 8 minus 20 would give us minus 12, plus 4 plus 8 would give us 0. So therefore, x minus 2 is a factor. Right, so that helps us get started. We now know that p of x can be written as x minus 2 times a quotient. To figure out what that quotient is, we're going to go through and do long division. So I'm going to get rid of this bit now because we don't need it. Right, so we're going to have x minus 2 as our divisor, and we're going to be dividing our polynomial, so our x cubed minus 5x squared plus 2x plus 8. So to get x to an x cubed, we'd have to multiply by x squared. So x squared times x gives us x cubed. X squared times minus 2 would give us minus 2x squared. Subtracting that, we've got minus 5x squared minus 2x squared, so minus 5x squared plus 3x squared. 2x squared will give us minus 3x squared plus 2x. Then to get this x to a minus 3x squared, we'd have to multiply by minus 3x. So that gives us minus 3x squared. Minus 3x times minus 2 would give us plus 6x. Subtracting that would give us minus 4x plus 8. Need a little bit more room. To get that minus 4x, we'd have to times by minus 4, which gives us minus 4x, and minus 4 times minus 2 would give us plus 8, which will leave us with a remainder of 0. So that tells us that this quadratic up the top is our quotient. So we're going to have x squared minus 3x minus 4. So we have partially factorized our original polynomial now, but we haven't fully factorized it, and it's not a product of its linear factors yet, because this second one isn't linear, it's still a quadratic, it's still of degree 2. But we know how to factorize quadratics, so we're going to have x minus 2, and you can use the PSF method or the cross method or whichever one you're comfortable with. But we need two things that multiply to give 4, so 4 and 1, and they need to multiply to give minus 4 and add together to give minus 3, so that would be minus 4 and plus 1. So this is our final answer. This is this original polynomial written as a product of its linear factors.